half. Okay, that's what we're going to do in this with complex numbers. Instead of dividing by a complex number, I'm going to turn it into a multiplication problem to make it a little bit easier. What we need to know is there is the concept of something called a complex conjugate. Okay, so the complex conjugate is just found by changing the sign of the imaginary part of a number. So here's the number 5 minus 3i. What number do I get if I change the sign of the imaginary part? 5 what? Plus 3i. That is the complex conjugate of 5 minus 3i. What's the conjugate of the next one? Negative 6 plus 2i. What's the conjugate of this one? Negative 2i. Okay. And what about the next one? Negative I. So I switched it up. This is 21 plus I. So really it's 21 minus I or negative I plus 21. Okay. So all I did is just change the positive negative sign of the complex part. Now the reason I do that is there's something very special happens when I multiply a number by its complex conjugate. So if I wanted to multiply a plus bi times a minus bi, okay, what would that work? So what do I get? What is a times a? A squared. Multiply the outside terms. Minus abi. Multiply the inside terms. abi. Multiply the last terms, and I get minus b squared I squared. Okay, that's just foiling that two binomials. Okay, what happens to these middle two terms? Yeah, those things become 0. Okay, so this becomes a squared minus b squared, and what is I squared? Negative 1. Okay, so this turns out to be what? A squared plus b squared. Okay, what kind of number is a squared plus b squared? Is it complex? It's real. Okay, so the reason why, if I multiply a number by its complex conjugate, I will get a real number. Okay, that's sort of the important step we need in order to divide by complex numbers. So let's do a few examples. What I would like to do is to do this particular operation. I want to take 1 plus 2i, and I want to divide it by 2 minus 3i. Okay, so the way I'm going to do this is I'm going to turn this into a multiplication problem. So 1 plus 2i over 2 minus 3i. What is the complex conjugate of the denominator? 2 plus 3i. So I'm going to multiply by 2 plus 3i over 2 plus 3i. Can I do that? Have I changed the number? What am I multiplying by? 1. I'm multiplying by 1 in the form of 2 plus 3i over 2 plus 3i. The reason I do that is because we just showed if I take a number and multiply by its complex conjugate, I get what kind of number? A real number. So this is going to make the denominator a real number. So all I need to do now is just do these two multiplications. I've got 1 plus 2i, 2 plus 3i on the top, and I've got 2 minus 3i, 2 plus 3i on the bottom. So what this does, division turns into two multiplication problems. Okay, so if I look at the top, what happens when I FOIL the top? What do I get? I get 2, and then what? Plus 3i, plus 2i. And what do I get from the last terms? The last two terms here. 6i squared over. Yeah, you're right. So it's 3i plus 4i. And then on the bottom, 2 times 2 is 4. And then I get what? Plus 6i minus 6i minus 9i squared. By design, the bottom, you're going to have that 6i minus 6. That's the reason I multiply by this, so that the bottom, those i's go away. So what do I get on the top? This is what? 2 plus 7i. And what is I squared? Negative 1. So this 2 plus 7i, what, minus 6 over, and this is 4 minus 9. What's I squared? Negative 1. Okay. So this becomes what? Negative 4 plus 7i over what? 4 minus negative 9 is, what's 4 minus negative 9? I'm going to go with 13, okay? So what is this final answer? I want my answer to look like this, A plus BI. What's the real part of that number? So it's negative 4 over 13 plus 7 over 13i. So all I did was multiplication here to get this answer, okay? But the key was I had to multiply by 1 in a special form. It was the complex conjugate of the denominator over itself. Okay, so really all this comes down to is when you divide, you turn it into a multiplication problem. Maybe I should have done this other one, it's easier. What is the conjugate? So this is 3 over I. What is the complex conjugate of I? Yeah, so it's just negative I. So I'll multiply this by negative I over negative I. What do I get on the top? Negative 3i. Okay. What do I get on the bottom? Negative what? I squared. What is I squared? Negative 1. So this is negative 3i over negative 1, which is just that 1. So the answer is negative 3i. This one to me is sort of interesting. 3 divided by I is negative 3i. When you just, sort of all that really happens is change the sign and move the I up to the top. Okay. Let's look at the next guy. 1 plus I over 1 minus I. So 1 plus I over 1 minus I. I will multiply this by what? 1 plus I over 1 plus I. I have to multiply it by both the numerator and the denominator because I'm multiplying by the number 1. Okay, so this becomes 1 plus I times 1 plus I over 1 minus I times 1 plus I. So what do I get in the top when I FOIL this? First terms give me 1. Yeah. So the outside terms give me what? Plus I plus I plus I squared. And then on the bottom, you multiply the first terms, you get a 1. The outside terms, you get I minus I squared. And now it's just a matter of simplifying. This is 1 plus 2i, and then I squared is what? Negative 1. Okay. This is, what happens to the I minus I? It goes away. This is 1 minus negative 1. Okay. So on the top, what is that 1 minus 1? 0. So this is 2i divided by 2, right? What's 2i divided by 2? I. There we go. That is the answer. Okay. So in all of these problems, they look complicated. The algebra gets a lot, and then it boils down to an answer that's simpler. Okay. So anyway, that's all it is to doing division. What do I have? Do I have a few more that are work? Okay. Let's do a few more and we turn you loose. What do I multiply this guy by? Yeah. So this is 2i over 1 plus I. I multiply by 1 in the form of 1 minus I over 1 minus I. And what do I get on the top when I multiply 2i times 1? I get what? 2i, and then minus 2i squared. what do I get on the bottom? Multiply the first terms, I get 1 minus I plus I minus I squared. So on the top, this is what? 2I minus 2 times -1. On the bottom, the negative I and the I cancel. So the whole design was this, is you should get the I terms to cancel on the bottom of this fraction. So this becomes 1 minus -1. So what do I have there on the top? On the top, I've got 2 plus 2I over 2. Now, how do I write this as a complex number? This is what? This is 2 over 2 plus 2 over 2I. What's another way of writing that? 1 plus I. Now, I like this problem because you take 2I and you divide it by 1 plus I and you get 1 plus I. So what do you think 1 plus I squared is? If you take 25 and you divide it by 5, you get 5. So what do you think 5 times 5 is? I'll do that again. You take 25 and you divide it by 5, and what do you get? 5. So what's 5 times 5? 25. We take 2I, we divide it by 1 plus I, and we get 1 plus I. What do you think 1 plus I times 1 plus I is? 2I. You can check that out. So 1 plus I squared should be 2I. Okay, so you should that one should come out. 5 over I plus 7. So this is going to be 5 over I plus 7 multiplied by what? Yeah, I minus 7 over I minus 7. On the top, I get what? 5I minus 35. On the bottom, oh wait, guys, you let me make a mistake. What was my mistake there? Yeah, I did I plus 7, I did I minus 7. Is that the complex conjugate? No, it is not. So I need to turn off autopilot. So it's better to write this as 5 over 7 plus I. Now I need to multiply by what? 7 minus I over 7 minus I. Okay, so this becomes what? 35 minus 5I, and then over, this is 49, and you get minus 7I plus 7I minus I squared. So this is 35 minus 5I. These 7 I's go away. This is 49 plus 1, which is what? 50. So you get 35 minus 5I over 50. So this is 35 over 50 minus 5 over 50I. So this is 7/10 minus 1/10 I. Okay, the next one you should be able to do without even any work. What is the next one? -3. So this one, I don't want to bother with the complex conjugate. Why? What kind of number is I squared? It's a real number. So this is 3 over -1. This is -3. This is the one you hope to get on a test, you know. And there we go. So